Hi, let's continue our calculation. So I think I made a mistake here again. It's all about how much you shrink or enlarge the equation, right? So if you choose a wrong one to shrink or enlarge your inequality equation, then you cannot get the result you expected for. So let's just redo this calculation. So we want to prove that RA, RB, RC divided by squat RA, RB plus RB, RC plus RC, RA. This is the area of the triangle. That's all equals to square 3, 2, 3 times RA, RB, RC 2 by 3, right? So the first thing I would do actually here is to just write this is equivalent to square of both sides, RA, RB, RC square 2 squat RA, RB plus RB, oh no squat, right? Plus RB, RC plus RC, RA. That's all equals to 1/3 of RA, RB, RC 4 by 3, right? Which is equivalent to prove that RA, RB, RC 2 RA, RB plus RB, RC plus RC, RA less or equals to RA, RB, RC 1/3, right? And now for this one, let's use mean inequality chain, right? So third RA, RB, RC 1/3 is larger or equals to, still we use this one, the geometry mean, right? And we know that here each one is RA, each xi is is RA, RB, RC, right? So it larger than 1 by 3 times 3, 2, larger than this one, larger than the harmonic mean, right? The harmonic mean, so because xi is RA, RB, RC, so it's 1 over RA plus 1 over RB plus 1 over RC, which equals to RA, RB, RC 2 RA, RB plus RB, RC plus RC, RA, which is the area of triangle, right? So we just prove that the area of triangle less or equals to this one. And this is true if and only if RA equals to RB equals to RC, right? So we just prove the property 5. And now let's look at the property 6. Okay. For property 6, now we want to calculate the length of IBIC, right? We want to find the relation actually between the IBIC and A is BC, right? We want to prove that IBIC equals to A times cosecant angle A divided by 2. What is cosecant? That's 1 over sine angle A by 2, right? We want to find this one. So for the IBIC, we know that IBIC can be calculated as IB times IC. No, not IB times IC, sorry. IBIC, that's the length, right? The IBIC equals to, we know the the radius of the circumcircle of triangle IA, IB, IC is 2r, right? So 2r times sine angle IC, IA, IB. That is how we calculate the quad, right? The IBIC equals to this one. And sine angle IC, IA, IB, we know that angle IC, IA, IB is 90 degree minus half. This one is so 4r times sine 90 degree minus half of angle A, right? So it equals to 4r times cosine angle A divided by 2, right? That is IBIC. And what is A? A is the length of BC, so A equals to 2 times r, right? Because the radius of the circumcircle of the triangle ABC is r, times the circular angle reference to the quad BC, which is sine angle A, right? And it can be rewritten as 2r times 2 times half of sine half of angle A cosine half of angle A, right? Which means it is 4r times sine angle A divided by 2 cosine angle A divided by 2, right? Sine angle A by 2 cosine angle A by 2, right? So look at these two. We know that IBIC equals to A times 1 over sine half of angle A, right? Which is A times cosecant half of angle A. So we just prove this one. For IC, IA and IAIB, they are the same. Right? They're the same cases. So just rotate the letters here. And now we want to calculate for IIA. Here, IIA. Notice that BICIA are cyclic, right? BICIA are cyclic. And the chord IIA reference to a circular angle IBIA, which is 90 degree. That means IIA is the diameter of the circumcircle of the ICIAB, right? Which means BC can be calculated as A equals to twice of the radius of this one, so which means the diameter of this one, that is IIA times sine angle BIAC, right? BIAC is 90 degree minus half of angle A, right? That means A equals to IIA times cosine half of angle A. So IIA equals to A times 1 over cosine half of angle A, which is A times secant half of angle A. Right? For the IIB, IICs are the same, so we just prove it. And based on these two properties, we have several corollaries here. So the first one, I don't think we need this for now. Okay, let's just do the calculation. The first one here is that we want to calculate for IIA times IIB2 and divided by A, right? And if you still remember that we have the relation of, and all of this equals to this one, right? So IIA times IIB. What is the relation of R and A? We know that R, let me find it here. I think I already write it here. See here. A equals to 4R times sine angle A divided by 2 times cosine angle A divided by 2, right? So That means let me just start from here. 4r equals to a times 1 over sine angle a by 2 times cosine angle a 1 over cosine angle a by 2, right? That is 4r. And it equals to a times 1 over sine angle a by 2. That is a times cosecant angle a by 2. And let's just times a here, times 1 over cosine angle, that times the second angle a by 2, right? And times 1 over a. So it equals to what? A times cosecant angle a by 2. That is IBIC, right? So IBIC times a times second angle a by 2. That is IIA. So 4r equals to IBIC times IIA divided by a. Okay, we just prove this one, right? For the other two, they're the same. And for this one, IBIC times ICIA times IAIB divided by ABC. Okay, so let's think about IBIC divided by A. IBIC divided by A equals to 1 over sine angle A by 2, right? So that means all of these equals to 1 over sine angle A by 2, sine angle B by 2, sine angle C by 2, right? And on the other side of the equation is relation between R and R, right? So if you remember, we already find the relation between R and R, right? So we want to calculate for the 4R by R, which is 4R by R, right? So these two are equal. That means 4R by R equals 2 cotangent angle B by 2 cotangent angle C by 2 times 1 over sine angle A by 2 cosine angle B by 2 cosine angle C by 2, right? And see cotangent angle B by 2, so it equals to 1 over sine angle A by 2 times cosine angle B by 2. 1 over cotangent, that is tangent, right? Times tangent angle B by 2 times cosine angle C by 2 tangent angle C by 2. We know that cosine angle B by 2 times tangent angle B by 2, that's sine angle B by 2. So it equals to 1 over sine angle A by 2 sine angle B by 2 sine angle C by 2. Now look at these two. They're equal, right? So this is true, which is this one is true. Okay, now we want to calculate for the area ratio of the triangle IAIBIC and the triangle ABC. Right. The first thing is that we want to calculate for the area of the triangle IAIBIC. And how can we do that? The triangle IAIBIC, right? It can be calculated as let me just find the easy way to do it. It has so many ways to do. I just want to find an easy way to solve it, right? So we want to calculate for the area area of the this one ICIB. Okay, we want to correlate the R to R, right? Okay, so the area of the triangle IAIBIC. Here, the area of the triangle IAIBIC. Let's just do the calculation directly. Okay, it equals to IBIC, half of IBIC times AIA, right? So this one times this one times half. And IBIC, we already know that IBIC equals to A times cosecant, which is A times I want to correlate the R because we want to have the R to R, right? So I want to put the R in it. Okay, that's fine. So it equals to A times yeah, I don't want to just have an A here, because once we have an A here, we have to correlate IA as well. Okay, let's do another way. Here. Let's consider IBIC times IIA, right? IBIC times IIA, it equals to IBIC times AIA minus AI, right? And we already know that IBIC times IIA here. So IBIC times IIA equals to 4R times A. So this one equals to 4R times A, right? So look at the figure here. We have IBIC times IIA equals to 4R times A, and IIA can be rewritten as AIA minus AI, right? And we know that IBIC times AI, that is twice of the area of triangle IAIBIC. And IBIC times AI equals to twice of the triangle area of IBICI, right? It equals to 4R times A. Okay, so similarly, we can write other equations as IBIA times IIC equals to twice of the triangle area of IAIBIC minus twice of the triangle area IBIAI equals to 4R times C, right? And also ICIA times IIB equals to twice of the area of triangle IAIBIC minus twice of the area of triangle ICIAI equals to 4R times B, right? So we add them together, and we know that the area of the triangle IBICI plus IBIAI plus ICIAI, that is the area of the triangle IBICIA. So it equals to 6 of the triangle area IAIBIC minus 2 of the triangle area IAIBIC equals to 4R times A plus B plus C, right? And we know that A plus B plus C, okay, so here equals to 4 of this one, IAIBIC equals to 4R A plus B plus C. And we know that A plus B plus C equals to twice of the triangle ABC divided by R, right? Which means IAIBIC equals to R times 2S ABC to R. So the area ratio of the IAIBIC to ABC equals to 2R to R. Okay? That's corollary 2. And for the corollary 3, let R prime be the radius of the circumcircle of triangle IAIBIC. R prime equals to 2R. We already proved that because based on the 9-point circle, it's obvious. Okay, now it's saying let the radius of the incircle of triangle IAIBIC to be R prime. Okay, little case R prime. And we want to find that IBIC plus ICIA plus IAIB divided by A plus B plus C equals to R prime to R prime. So let's just rewritten this one. We basically want to prove that IBIC plus ICIA plus IAIB times R prime equals to A plus B plus C times 2R, right? And from this one, we already know that R times A plus B plus C equals to the area of the triangle IAIBIC, right? That means this one, this side, is twice of the triangle area IAIBIC. And for this one, it's actually twice of the area of triangle IAIBIC, right? Just look at the figure. We have the radius of the incircle of this triangle IAIBIC, and each side add them together times R. That's twice of the area, right? That's obvious. So this is true. And the corollary 5, we want to prove that 1 over IIA squared plus 1 over IBIC squared equals to 1 over A squared. Because IIA equals to A times 1 over cosine angle A by 2, right? And IBIC equals to A times 1 over sine angle A by 2. So if we do this one, 1 over IIA squared, that is 1 over A squared times cosine squared angle A by 2. And for this one, IBIC, 1 over IBIC squared, that is 1 over A squared sine angle A by 2, right, squared. So if we add them together, so we know that 1 over IIA squared plus 1 over IBIC squared equals to 1 over A squared. Okay. And for the next one, we want to prove that IA to BC plus IA squared to BC plus IB squared to CA plus IC squared to AB equals to 1. Right? So let me just mark it here. BC is actually A, right? And AC is B. AB is C. We know that this angle, the angle IAC equals to angle BAI equals to angle BICC. So basically this angle equals to this angle equals to this angle. And this one, let me see, this one, right? This one equals to this one equals to this one. So you can see that triangle ACI is similar to triangle IAICI, right? Actually, triangle ACI is similar to triangle ICIAI, right? That means AI to B, IA to B equals to IA to B equals to IIC to ICIA. Right? We want to prove this one. And we know that IA to B equals to IIC to ICIA. Also IA to C, because similarly we have this triangle ABI is similar to triangle IBIAI, right? So AI to C equals to IIB to IBIA. So we can calculate IA squared to BC, that is IIC times IIB to ICIA times IBIA, right? It's IIC times IIB to ICIA times IBIA. So the question is that what is this angle? The angle ICIIB equals to angle BIC, which is 180 degree minus angle BIAC, right? So for the sine, this angle would be equals to this angle. That means we can rewrite this as we just simply times sine angle ICIIB, right? ICIIB. And the bottom is sine angle ICIAIB. They equal, right? So it equals to, let's just do half here. That's the area of triangle ICIIB to the area of triangle ICIAIB. Okay, that's IA squared to BC. And similarly, we can find that IB squared to CA equals to the area of triangle ICIIA to the area of triangle ICIAIB. And also IC squared to AB would be the area of triangle IBIIA to the area of triangle ICIAIB, right? And then we sum them together. The summation of the triangle area ICIBI, IBIAI, and ICIAI would be the area of triangle IAIBIC. So that equals to 1, right? So we got IA squared to BC plus IB squared to CA plus IC squared to AB equals to 1. Okay, that is true. And next, we want to prove that IA plus IB plus IC less or equals to square root BC plus CA plus AB. Right, we want to prove that IA plus IB plus IC less or equals to BC plus CA plus AB. So for this one, we actually need to use a Cauchy inequality, right? Which is, let's say we have two set of the numbers. One is x1, x2, all the way to xn, right? And also we have another set of numbers. They are in the equal amount. y1, y2, and all the way to yn, right? So we have that I think we have that x, I, y, I, we times them together and square is less or equals to xi square from 1 to n times I equals to 1 yi square. Right, that's Cauchy inequality. And let's just think about what we have here, and we can bring this one to be IA divided by square BC times square BC plus, that's IA plus IB divided by square CA times square CA plus IC divided by square AB times square AB, right? That is IA, IB, IC. So for this one, we just need to prove it's equivalent to prove that IA plus IB plus IC squared less or equal to BC plus CA plus AB, right? So we just do this one square, which is exactly IA plus IB plus IC square less equals to, we use Cauchy inequality. So here we do this one. So the summation of this square, that would be IA2 square BC square plus IB2 squared CA square plus IC2 squared AB square times BC square squared CA square plus squared AB square. Right, and we know this one is IA squared to BC plus IB squared to CA plus IC squared to AB, right? That's the first term, and the second one would be BC plus CA plus AB. And for this one, we already know it equals to 1. So we just prove that IA plus IB plus IC square less or equals to BC plus CA plus AB. Okay, so that is property 6. Okay, let's see property 7. Property 7, actually for this one, the audience can just read about it and see we actually already prove it at the very beginning that we want to prove the BD equals to CG. We already proved all of these. Okay, so I'll just skip the property 7. And for the property 8, I need to redraw the figure. So let me just redraw the figure first. I want to have a circle. And let me draw the triangle here. Right. This is IA, and this is D. Okay, what does it say? It's saying let AIA meet the circumcircle of the triangle ABC on D. Then prove that DIA equals to BD equals to DC. So DB equals to DC is very simple, just because this angle equals to this angle, right? Because D is on the angle bisector or angle BAC, that means this angle equals to this angle. So the circular angle are equal, that means the chord are equal, right? So BD equals to DC. And now we want to prove that DIA equals to BD as well. So for this one, just think about that we have the let me draw it. Right, this is IB. This is I. And we know that, so because we want to prove BD equals to DIA, basically we can say, oh, if we can prove that this angle, the angle DBIA equals to angle DIAB, then we prove that BD equals to DIA, right? And we know that angle DBIA, angle DBIA plus angle DBI, angle DBI, this angle equals to 90 degrees. Right, so this angle plus this angle equals to 90 degrees. And what is this angle? It can be rewritten as, so let's just expand it. Angle DBIA plus angle DBC plus angle CBI equals to 90 degrees, right? And angle DBC, that is angle DAC, which is half of angle A. So angle DBIA plus half of angle A plus angle CBI, that is half of angle B, equals to 90 degrees. So we know that angle DBIA equals to half of angle C. Right, so this angle is half of angle C. And we know this is 90 degrees, right? What about this angle? Let me just do this. What about this angle? The angle BIIA equals to angle BAI plus angle IBA, which is half of angle BAI, that's half of angle A, IBA, that's half of angle B, right? And we know that this angle BIIA plus angle BIAI equals to 90 degrees, which means angle BIAI equals to 90 degrees minus angle A divided by 2 plus angle B divided by 2, so it equals to half of angle C. So we got that angle BIIA equals to angle BIAI, right? Angle BI, oh wait, no, this one equals to this one. The angle DBIA equals to angle BIAI. Angle DBIA, this one equals to angle BIAI equals to this angle, which means BD equals to DIA. Okay. So that is property 8. For the property 9, the angle IB, IA, IC equals to this one. That is 90 degrees minus half of angle A. So actually we already proved that. And angle IA, IB, IC, IA, IB, IC, that is 90 degrees minus half of angle B, which is this one, right? So this property 9, basically we already proved that. We don't really need to do it again here. For property 9, for property 10, for certain triangle, let's consider we're talking about the triangle ABC here. For certain triangle, an excenter can form 3 triangles. So an excenter, let's just choose excenter IA here. An excenter can form 3 triangles with 3 edges, right? That means we are forming the triangle IABC, IABA, IACA, right? 3 edges. The ratio of the 3 triangle areas equals to the ratio of the 3 edges, right? That is straightforward because the area of the triangle IABC is calculated by RA times BC times 0.5, right? Half of RA times BC. And the area of triangle IAAB is calculated by half of AB times RA. So the area of the triangle IAAC is half of AC times RA, right? So the ratio of these 3 triangles would be the BC to CA to AC. That's the ratio of the 3 edges, right? For certain triangles, 3 excenters can form 3 triangles with 1 edge, which means let's just choose the edge BC. We have 3 triangles here, would be IA, BC, IC, BC, IB, BC, right? And the ratio of the 3 triangles area equals to the ratio of the radius of the 3 x circle. That's obvious because the area of the triangle BC, IA would be half of BC times RA. For the area of the triangle ICBC would be half of the BC times RC. And for the area of the triangle BCIB would be half of BC times RB, right? Then the ratio would be RA to RC to RB, right? Okay, property 11. Let's just draw it here. A line passing through the excenter IA. So let's draw a line here. Passing through the excenter IA meet line ABAC on PQ. This is P, this is Q, right? Respectively. And we want to prove that AB to AP times sine B plus AC to AQ times sine C equals to this one. So for this one, actually, we should be very familiar because this kind of form already occurs in the orthocenter, in the centroid in the incenter, in the circumcenter, right? We should be already familiar with this kind of form, but let's do the calculation here. Notice that it's sine B, sine C, sine A, right? So we can directly replace the sine B, sine C, sine A to AC. For sine C, that would be AB, right? And for sine A, that would be BC. So we actually can reform the this formula to be this equation to be AB to AP times AC plus AC to AQ times AB equals to minus BC plus AB plus AC, right? We can simply rewrite this equation to be this one. That's the same, right? Okay. Now if we consider about proving this one, we actually can reform the left side of the equation to be ABAC2 APAQ and AP plus AQ, right? And equals to minus BC plus AB plus AC, right? So basically we want to prove that ABAC2 APAQ equals to minus BC plus AB plus AC to we want to do this, right? We want to prove this. And we already know that ABAC2 APAQ equals to the area of the triangle ABC to the area of the triangle APQ, right? If we find the RA from the IA here and to here, right? We know the area of the triangle ABC can be calculated as a half of P minus A times, not half, P minus A times RA, right? That's a property we already learned. And for the area of the triangle APQ can be calculated as a half of AP plus AQ times RA, right? Because APQ can be calculated as a triangle area APIA plus AQIA, and APIA would be AP times RA. AQIA would be AQ times RA and times 0.5, right? So which means P minus A divided by half 0.5, that is minus A plus B plus C times RA cancel each other divided by AP plus AQ, right? So minus A plus B plus C, that's minus BC plus AB plus AC, AP plus AQ. So we just prove they're equal, right? Okay. So we spent almost 2 hours to demonstrate the properties of the Excenter. I hope you have a basic idea of what we are talking about here, basic idea of the Excenter, and then we can use these properties for the further problem solving. Okay, I hope you like this video. I hope you like the concept and the calculation here. See you in next one. Thank you.